Hey class, Miss Anderson here. Today I'll walk you through some right triangle trig review. So most of this will be review. We will learn a couple new trig ratios today, but let's first recall the ones you've already learned in geometry. We have sine, cosine, and tangent, and we have sine is going to be your opposite side over your hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent is opposite over adjacent. You can pause this and write those down. We will have a diagram here later on and show you which sides go with which again to remind you. Remember we learned SOHCAHTOA to help us remember the definitions for sine, cosine, and tangent. So SOHCAHTOA stood for where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So hopefully that looks familiar. We also will use the Pythagorean theorem, which says the sum of the sides squared equals the hypotenuse squared. So that's another useful one to remember. And so the legs, it doesn't matter which one is A and which one is B, but the hypotenuse is always C. And that's A squared plus B squared equals C squared. And the new ones you're going to learn today are the reciprocal functions for sine, cosine, and tangent. So cosecant is the reciprocal of sine. So cosecant is the same thing as 1 divided by sine of an angle. And since it's the reciprocal, sine is opposite over hypotenuse. So cosecant is going to be hypotenuse over opposite. Secant is the reciprocal of cosine. So secant goes with cosine. So since cosine is adjacent over hypotenuse, you'll find the secant value by taking hypotenuse over adjacent. And then we have cotangent. That's the easiest one to remember because it has the word tangent in it. It is the reciprocal of tangent, which is adjacent over opposite. So those are the three new ones. Let's look at it with a triangle. So we have our triangle here. It's a right triangle, and this is our angle. Our sides are labeled based off of where the angle is located. So the side that is touching the angle is considered to be the adjacent side. That's what the word adjacent means. The side that is across, the leg that is across from the angle is considered to be the opposite side. And then the hypotenuse is always the largest side, and it's always across from the largest angle, which is your 90-degree angle. So adjacent and opposite might change based on where your angle is located at. And then the hypotenuse is always across from the 90 degrees. So if I draw the same triangle, but I move my angle to up here, then this becomes my opposite, this becomes my adjacent, and the hypotenuse is still the across from the 90. So to go with the 6 ratios then, you'll find the sine of an angle by taking the opposite side over the hypotenuse. So this is our basic SOHCAHTOA, and sometimes when I write this, I write it like this, SOHCAHTOA. So that reminds me that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then the new ones are the reciprocal functions. So cosecant, which is abbreviated as CSC, this one is called cosecant. It goes with sine, so it's the inverse of, or the reciprocal of sine, so it's hypotenuse over opposite. Secant, which is abbreviated SEC, goes with cosine, so it is the reciprocal hypotenuse over adjacent. And then COT is the abbreviation for cotangent, and it's the reciprocal of tangent, so it's the adjacent side over the opposite side. So take a second, make sure you get those down correctly. Then we're going to go on and use this to evaluate the 6 trig functions given the sides of a right triangle. So our angle is in the top right corner, so the side across from it is going to be our opposite side. The side next to it is going to be our adjacent side, and then our longest side and also the side across from the right angle is going to be our hypotenuse. So we find sine is going to be opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent for those three main ones. So sine will be 12/13 because the opposite side is 12, the hypotenuse is 13, which means the cosecant, CSC, will be the reciprocal 13 over 12. Cosine is adjacent over hypotenuse, so that's going to be 5 over 13. And secant is the reciprocal of that, so 13 over 5. We're going to leave our fractions as improper fractions, so 13 over 5, not a mixed number. We also would simplify if we could, and we want to leave it in fraction form, a ratio of side lengths, not as a decimal. Tangent is going to be opposite over adjacent, so 12 over 5, and cotangent will be the reciprocal 5 over 12. Again, leaving them as ratios of side lengths, no decimals, no mixed numbers, etc. Okay, we're going to do this again, but this time I gave you the legs of the hypotenuse or the legs of the right triangle and not the hypotenuse. So you'll have to use the Pythagorean theorem to solve for the hypotenuse. It doesn't matter. This one could be A, this one could be B, this one could be B, this one could be A. That doesn't matter. What matters is that your hypotenuse is C. That's key. And then the Pythagorean theorem is a squared plus b squared equals c squared. So the sum of the square of the legs equals the hypotenuse squared. So that would give me 10 squared plus 5 squared equals c squared. That's 100 plus 25 equals c squared. So the square root of 125 is going to give me 5 square roots of 5 in simplified radical form. So 5 square roots of 5. Now my angle is in the top right corner again, so this 10 is going to be my opposite side. The 5 is touching it, so that's my adjacent side, and then this is my longest side. If you did do the decimal, the square root of 125, you're going to see it's going to be 11.18, so it is bigger than both of the legs. The hypotenuse is always the biggest side. So SOHCAHTOA, sine is going to be O over H, C is A over H, and tangent is opposite over adjacent. So SOHCAHTOA. So sine will be opposite over hypotenuse. Now we're going to reduce this a little bit and rationalize it. So first, 10 divided by 5 simplifies to 2 over 1, and then we got to multiply by the square root of 5 on both the top and bottom to rationalize our answer. So we're going to get 2 square roots of 5 over 5 as a final answer there. Now, if we go for our reciprocal function, go back to the original and take the reciprocal of that. So 5 square roots of 5 over 10. Then simplify 5 over 10 is 1 over 2. So square root of 5 over 2 for that one. Cosine is adjacent over hypotenuse. So 5 over 5 square roots of 5. Again, we can simplify. 5 divided by 5 simplifies to 1, and then rationalize. And then we get 5 square root of 5 times 1 square root of 5 over 5. And then for secant, take the reciprocal of the original, so hypotenuse over adjacent, and then simplify to square root of 5. And then tangent is opposite over adjacent, and 10 divided by 5 simplifies to 2. Cotangent would be adjacent over opposite, and that's going to simplify to 1 over 2, or 1/2. So you will have to practice these and make sure you know which ones go with which. I've lined these up nicely, but they are not lined up nicely in your homework or in your workbook. So make sure you pay attention to which ones go with which so that you get used to identifying the reciprocal functions correctly. We can also use right triangle trig to help us solve a right triangle. Solving a right triangle means finding all of the missing side lengths and angles. So we have one side length and one angle. Finding the missing angle is the easiest because we know that the angles in a right triangle add up to 180 degrees, and we have a 90-degree angle there, so that means that angle A and angle B must equal 90 together. So if you take 90 minus 62, you will get 28, and that's going to be your measure of angle A. So that's one of our answers. Okay, and we know the measure of angle B, and then we can solve for our B and C values. When I'm solving a triangle, I always stick with the angle that was given, and I label my triangle based off of that. So 62 degrees was given, which means B would be my opposite, 6 would be my adjacent, and C would be my hypotenuse. And I got that email from you. I think I lost that sheet. I'll take it again. I'll see him on Monday. Thanks. Okay, sorry about that. So we are going to use that as the side lengths, and then I'm going to set up a trig functions to help me solve for the opposite and the adjacent. So if I want to solve for one of these, if you think about SOHCAHTOA, I am given and currently the adjacent side. Whoops. So I can either use cosine to solve for the hypotenuse or tangent to solve for the opposite. So I'm going to start with tangent. I can't use sine of that angle because I don't know the opposite and I don't know the hypotenuse. So you got to pick one that you know. So if I do tangent of the angle 62 degrees would be equal to B over 6. Got to try to make my B's and my 6's look different. Then solve this for B. This is divided by 6, so I would multiply by 6 on both sides to cancel that, and that gives me what B equals. So then make sure that your calculator is in the right mode. You want to be in degree mode, so if radians is highlighted, you have to switch it, hit enter, and then hit exit. You gotta do 6 times the tangent of 62. You should get 11.3 about. Okay, so there's another answer, and then we have to solve for C. You could use the Pythagorean theorem here. You would want to write down a couple more decimals so you don't round too early if you're going to use the Pythagorean theorem, or we can use cosine. So cosine of angle 62 would be equal to adjacent side, which is 6, over the hypotenuse, which is C. There's 2 steps involved in solving this one though, because first you have to multiply by C to get C out of the denominator over here. And then we get C times the cosine of 62 equals 6. So then to get C by itself, we have to then divide by the cosine of 62 on both sides. So it ends up being C is 6 divided by cosine of 62 degrees, which is approximately 12.8. And now I found my missing side lengths and my missing angle, and so the triangle is solved. All right, we're going to do it again, but this time we're only given 2 side lengths, and so we need to find the 2 angles, and we need to find the missing side length. The missing side length happens to be our hypotenuse, so we can label these A and B in any order and use the Pythagorean theorem to find our missing side length. So 11 squared plus 18 squared equals C squared. It's 121 plus 324, which is 445. The square root of 445 is approximately 21.1. So that's what we'll say this side length is. And then to find the missing angles, we have to use inverse trig. And so if we're looking for angle P here, angle P, 18 would be opposite, and this would be adjacent to angle P. So if I wanted to find the measure of angle P, I would say that the tangent of angle P is equal to 18 over 11. And then since what we know about inverse functions is that they switch the input and output switches when you do the inverse. And remember your inverse notation was to the -1. So if you find that button, that's the inverse, then you switch your input and your output. So when you type in the inverse tangent of 18 over 11, it will actually give you the angle measure. The inverse buttons on this calculator are just above the regular buttons. And notice the inverse notation is to the -1 power, so that's what you're looking for. So 18 over 11 gives me P is about 58.6 degrees. And then we could do the same thing for angle N, but if we look at angle N, then this is my opposite side and this is my adjacent side. So tangent of angle N would be 11 over 18. So if we did the inverse, we could switch the input and output, and that would give us our angle measure. Or I guess you could have took the angle that you found for P and subtracted it from 100 or from 90 degrees, because these two angles should make up 90 degrees together. So angle N was 31.4 and 58.6, which does add to 90 because we want a total of 180 degrees in that triangle. All right, one more. Right triangle trig is often used in application problems as well. So, for example, if you measure a flagpole, the classic flagpole problem. So you got a flag here, whoops. And you are standing 20 feet from the base of the flag. We're assuming the flag is making a 90-degree angle with the ground. Angle of elevation is the angle that's formed from the horizontal up, so that's right here, 65. Find the height of the pole. So angle of elevation is 65 from where you're standing 20 feet away. Find the height of the flagpole. So based off of the 65-degree angle that was given, I have looking for the opposite side given the adjacent side. Opposite over adjacent goes with tangent, so that's what you need to use. Tangent of 65 will be equal to x over 20, and then solve for x by, since it's divided by 20, the inverse operation would be to multiply by 20. So 20 times the tangent of 65 is going to be 42.9 feet. Okay. Hopefully that didn't get too long. There's lots of things to cover there. Have a great day. Thanks for watching.